Hello, hello, hello. Okay, I think I'm live. Just hello, hello. Okay, so guys, Happy New Year. And we streamed yesterday. I don't think anyone is watching. Okay, there is only one live watching, and that is me viewing your chats. So not a problem. So I learned yesterday about CS50's Python programming. Okay, so I watched the video directly. I shouldn't have done that. I should have done some research. Okay, so I think the Professor David Malan is offering this course for free on this Harvard website. Okay, I don't claim any credit for this. I'm just a student. I'm learning. Okay, so I'll be learning this from here. I think now because this is the platform he has designed especially to provide the course for free, like education and everything. So I've checked this out. I've installed the Visual Studio Code like yesterday, and I've done the exercise that we saw yesterday on Visual Studio Code. So this is the exercise I've done from what I learned yesterday. So let us check if it is working. So I think Python space hello .py was the code for running this. So we'll run this and see that if it is working. Okay, so I'll put my name. My name is Raza. If you don't know, my name is Raza. Okay, so the channel is based on my name, so it's not a quirky name, it's just my name that I have put in the username. Okay, we'll enter it and it should say that hello Raza. If it doesn't say that, and then we'll correct some code. Okay, so basically it says hello Raza. It told us two tricks to use this. Okay, we can add the plus sign also, but if we add the plus sign in just a minute. Okay, so if we add the plus sign and then we run the code, so it will ask for the name. Okay, then it will not print the space in between, so we'll have to add the space manually at this this place. Okay, so that was the thing. This was the comments. This was the comments. Now we'll continue with this course from here. Okay, so we'll take the course. We have watched the first week, the first video till 35 minutes I think. So we'll continue it watching, and he has provided notes and everything, so I don't think like yesterday I have to take notes again. So I'll be just seeing the notes which he has provided. Okay, like see this one are the notes. So I'll take a quick review after I finish the video on these notes. Not quick review, we'll take a detailed review. We'll read one by one and we'll try to understand everything topic by topic. Okay, because this is I think a very short course but very deep course. It is important that I learn this in detail. I do my fundamentals properly, then I can start working properly. Okay, so first we'll pause the video. I think this is the video. Okay, we start it. We can watch it on YouTube, because YouTube we can take this chapters and everything. I think we reached somewhere here, name parameters and everything, so we'll watch it from here.
Well, let me come.
And we'll keep the Visual Studio side by side. Okay, so we can just diminish this a little bit. Okay, this setup is good I think. Okay, so we can see the video here and we can practice this here. Okay, so we're on the same page as him, so we'll go with him only. Okay,
Back to the code here. in question and see if we can't show you just a couple of other ways to solve the same problem along the way, emphasize these string. Succinct, to the point, so we tend to use fairly short phrases to describe things, not necessarily full words. So while you might say string, technically in Python what we're really talking about, these sequences of text, are technically strs. This is an actual type of data in a program. But we'll soon see that there's other types of data in programs as well. In fact, let's see if we can't improve this in one other way. I like the progress we've made by keeping everything on the same line. Hello, comma, David. All on the same line. What more, though, could we do in terms of solving this problem? Well, it turns out that we didn't have to give up entirely with using print twice. Let me rewind a little bit and go back to that earlier version where I wasn't really sure how to solve this problem. So I was using print once to print out just the hello and the space and the comma. And then I used print again to print name. That, strictly speaking, wasn't bad, but there was this visual side effect that I just didn't like. It just looked ugly to have these two lines of text separate from one another. But there's another way to fix this. Clearly, it seems to be the case that the print function is automatically outputting a blank line. It's moving the cursor automatically for me to the next line, because that's why I'm seeing hello on one line and David on the next, and then my prompt, the $sign, on the line below that. So print seems to be presuming automatically that you want it to move the cursor to the next line after you pass it some argument. But you can override that behavior. Again, functions take arguments, which influence their behavior. You just have to know what those arguments are. And it turns out that if we look at the documentation for Python's print function, we can actually look up at this URL here. docs.python.org is where all of Python's official documentation lies. If I poke around, I can find my way to, more specifically, this URL here, where I can find all of the available functions in Python and the documentation therefore. And if I go a little more precisely, I can even find specific documentation for the print function itself. And rather than pull that up in a browser, I'm going to go ahead and highlight just one line from that same URL, which is this. And this is easily the most cryptic thing we've seen yet. But this is the official documentation for the print function. And one of the best things you can do when learning a programming language is, honestly, learn to read the documentation. Because truly, all of the answers to your questions will in some way be there, even though, admittedly, it's not always obvious. And I will say, too, Python's documentation isn't necessarily the easiest thing, especially for a first-time or a novice programmer. It, too, just takes practice. So try not to get overwhelmed if you're not sure what you're looking at. But let me walk you through this example. This, again, is a line of text from Python's official documentation for the print function. What this indicates as follows is this. The name of this function is, of course, print. Then there's a parenthesis over here and another closed parenthesis way over there. Everything inside of those parentheses are the arguments, the potential arguments to the function. However, when we're looking at these arguments in the documentation like this, there's technically a different term that we would use. These are technically the parameters to the function. So when you're talking about what you can pass to a function and what those inputs are called, those are parameters. When you actually use the function and pass in values inside of those parentheses, those inputs, those values, are arguments. So we're talking about the exact same thing. Parameters and arguments are effectively the same thing, but the terms you use from looking at the problem from different directions when we're looking at what the function can take versus what you're actually passing into the function. So what does this imply? Well, this syntax is pretty cryptic. But at the moment, just know that an asterisk, a star, and then the word objects means that the print function can take any number of objects. You can pass in 0 strings of text, 1 string like I did, 2 strings like I did, or technically infinitely many if you really want, though that code's not going to look very good. After that, we see a comma. Then we see another parameter here called sep, short for separator in English. And notice the equal sign and the single quote, space, single quote. So quote unquote space. I don't know what that is yet, but I think we've seen a hint about it. Let's focus, though, for a moment on this. The print function takes another parameter called end, and the default value of that parameter is apparently, based on this equal sign and these quotes, \n. And what is \n, if you'd like to chime in the chat? Anyone who's programmed before has probably seen this, though if you've never programmed before, this might look quite cryptic. \n means new line. And it's a way textually of indicating if and when you want the computer effectively to move the cursor to the next line, create a new line of text. And so technically, if we read into the documentation, we'll see more detail on this. The fact that there's a parameter called end in the documentation for the print function just means that by default, this print function is going to end every line with \n. You don't literally see \n. You see a new line. You see the cursor moving to the next line. Now, by that logic, let's move backwards. Sep for separator. The default value of separator is apparently a single blank space. Well, where have we seen that? Well, recall in an earlier example, when I passed in not just one, but two arguments to the print function, recall that they magically had a space between them. In fact, they had that space plus my own space, and that's why I deleted my space, because at that point it was extra. So this just means that when you pass multiple arguments to print, by default they're going to be separated by a single space. By default, when you pass arguments to print, it's the whole thing is going to be ended with a new line. Now, just by knowing this, and let me literally wave my hand at the rest of the documentation for another day. There's more things that print can do, but we're going to focus just on sep and on end. Let's see if we can't leverage this now to solve that original problem. The original problem was this. I don't like how hello, comma, David is on two different lines. Well, that's happening again because print is automatically printing out a new line. So let's tell it not to do that. Let's tell it by passing a second argument to the first use of print to say end equals quote unquote, not \n, which is the default automatically. Let's make it quote unquote nothing else. Let's override the default value so there is no new line. There's literally nothing there. And let's see what happens. Let me now go down to my terminal window and clear it. And I'm going to run Python of hello.py enter. I'm going to type in my name, David. And I think now everything's going to stay on the same line because, and it did, this line here, 5, is going to print out hello, comma, space, but then nothing at the end of it because I changed it to be quote unquote. The second line is going to print the name, David, or whatever the human's name is, and it will move the cursor to the next line because I didn't override the value of end there. Just to see this more explicitly, if you do something cryptic like, well, I have no idea what's going on. Let me just put in temporarily 3 question marks here. We'll see the results of this too. Let me go back down to my terminal window, run python of hello.py, what's your name, David, and now you see literally really ugly output, but you see literally what's going on. Hello, comma, space, then 3 question marks end that print statement, and then you see DAVID. So not a good outcome, but it demonstrates just how much control we have here too. And let me rewind further. Recall that in our other version of this, when I passed in hello, comma, and name, they were separated by a single space. So Python of hello.py, DAVID, enter. That just worked. Well, what if we override the value of sep for separator? Instead of being one space, we could say something like question mark, question mark, question mark, just to wrap our minds around what's going on there. Let me now do Python of hello.py, DAVID, enter, and you see 2. These 2 inputs, hello, comma, and the name, are now separated in an ugly way by 3 question marks because I've overridden the default behavior of sep. And even though the documentation uses single quotes, I've been in the habit of using double quotes. In Python, you can use either. Strictly speaking, it doesn't matter, but you should be consistent. And I generally always use double quotes. Python's documentation, though, always uses single quotes. Questions now on these types of parameters. And allow me to propose that we give these an official name. Up until now, when we've been passing values to print, those are called positional parameters. Positional in the sense that the first thing you pass to print gets printed first. The second thing you pass to print after a comma gets printed second, and so forth. But there's also these things we've now seen called named parameters, named SEP, separator, or end, END, for the line ending. Those are named parameters because, 1, they're optional, and you can pass them in at the end of your print statement, but you can also use them by name.
This may be a weird question, but I was wondering, what if someone wants to like add actually quotation marks within the quotation marks?
Yeah, I like how you think. This is what we would call a corner case, right? Just when we've made, right? This is all sounding great, at least as programming goes. But wait a minute, what if you want to print a quote? That's a really good question. Well, let's see if we can't figure this out. Suppose that I want to print out not just the user's name. Let me simplify this further. Let me go ahead and get rid of a lot of this. And let me just say something like, hello. Maybe I'm being a little sarcastic here. Hello, friend. In that kind of tone. Well, this is not going to work, actually, because you are trying to use quotes to be like friend in finger quotes, but you're also trying to end the sentence. And if I try running this, let's do this. Python if hello.py, you'll see that this is just invalid syntax. Perhaps you forgot a comma. And this is actually a bit annoying. Sometimes the error messages you see are misleading. Like the computer, the language doesn't really know what's going on, so it gives its best guess, but it's not necessarily correct. But I can solve this problem in a couple of ways. I can do this. I can change my outermost quotes to single quotes, because recall a moment ago I said you could use double quotes or single quotes so long as you're consistent. So that's fine. If you use single quotes on the outside, you can then use double quotes on the inside, and you'll see them literally. So for instance, if I run python if hello.py, there we go. Hello, friend. But there's another way. If you insist on using double quotes, as you might want to, just to be consistent, you can also use that backslash character again. We saw the backslash n a moment ago, and that meant we don't want a literal n to be in the output. We wanted a new line. So the backslash actually represents what's called an escape character. An escape character is one that you can't just type necessarily once on your keyboard. You need to express it with multiple characters. So I can actually put backslashes in front of these inner double quotes so that the computer realizes, oh, wait a minute, those aren't quotes that finish or start the thought. They're literal quotes. So now let me go back to my terminal window, run python of hello.py, enter, and now it's working as well. So escaping is a general technique that allows us to do that too. And if I may, let me rewind now on these examples and go back to where we left off with my code. I'm just undoing all of that because I want to get back to the point ultimately of specifying now a final way of solving this problem. Well, it turns out that we have yet another way we can solve this problem, which is perhaps the most frequently done now, or at least the most elegant when it comes to setting us up for longer and longer uses of strings. You can use a relatively new feature of Python that allows you to do this. You can literally put not the name of the variable like that in your string, because we already saw this is wrong, right? If you do this, you will literally see hello, comma, name. But what if I do this? What if I put curly braces or curly brackets around the variable's name? Notice VS Code is actually very subtly changing the color of it. So VS Code knows something interesting is going on here. Let me run this program, but I'm not done yet. Python of hello.py, enter. david, enter. OK, obviously not what I want. But I need to tell Python that this is a special string. This is what we're going to call a format string or an F string, a relatively new feature of Python in the past few years that tells Python to actually format stuff in the string in a special way. And the symbol via which you do this is a little weird, but this is what the world chose. If you put a F at the beginning of the string, right before the first quote mark, that's a clue to Python that, ooh, this is a special string. Let me format this in a special way for you. Let me now rerun the program. Python hello.py, enter. david, enter. And now we see the goal this whole time, hello, comma, David. We don't start with this way, because I think if we did this the first way, you'd be like, why are we doing this? What are all these magical symbols? But this is just yet another way to solve the same problem. But let me propose that we consider now yet other things we can do with strings. And it turns out that even as we've been doing some relatively simple operations here, we've generally been trusting that the user is going to cooperate. And that is to say that they're going to actually type in what we want them to type. Now, just because they type a string, though, doesn't mean it's going to look the way we want. You and I, honestly, as humans, are actually in the habit on websites and apps of like accidentally hitting the space bar a lot, either at the beginning of our input or at the end. Maybe because the space bar tends to be so big, it's pretty common to get accidental spaces before or after some user's input. You and I are definitely in the habit of not necessarily capitalizing words like we should. If we're sending text messages, we're probably being a little quick and just sending everything in lowercase, for instance, if that's your style, if your phone's not fixing it for you. Maybe in a formal letter, you would capitalize things properly. But you and I, as humans, we can't really be trusted to type things in a nice way necessarily when using some piece of software, be it an app or a website or something else. But it turns out that strings themselves come with a lot of built-in functionality. And you can see all of that in Python's own documentation here. The string data type that we've been talking about comes with a lot of functionality built in that means that we can manipulate the user's input to do more than just join it with something else, like hello. We can actually clean it up or reformat it in a way that hopefully looks a little better for us. So let me go back to my code here. And let me just demonstrate what might happen if a user doesn't cooperate. If I go ahead here and run Python of hello.py, enter, let me just sloppily hit the space bar a few too many times. Why? I just wasn't paying attention. And now I'm going to type in my name, DAVID, and I don't know, I hit the space bar a couple more times. Like, it's kind of a mess. It's all lowercase. That's not going to necessarily look grammatically right. It's got spaces here and here. The program is going to print exactly that. And that looks really bad, at least if we're prioritizing aesthetics and grammar. Like, why are there so many spaces after the comma? This is not a very nice way to greet your users. But we can clean this up. It turns out that built into strings, which again is this data type, so to speak, this type of data in Python, is the ability to actually do things to that string. So let me do this. I can actually go ahead and do something like this. Name equals name.strip. And what does this do? Remove white space from string. And what do I mean by this? Well, on the right-hand side, notice I've written the variable name called name. I've then used a period or a dot. And then I seem to be doing what's a function, right? Anytime we've seen a function thus far, we see it's the function's name, print or input. Then we see a parenthesis, then another parenthesis. And that's exactly what I see here. But I'm using this function a little differently. Technically, this function is, in this context, called a method. And what do I mean by that? Well, if name is a string, aka stir, well, it turns out, according to the documentation, there's a lot of functions that come with strings in Python. And you can access that functionality by using the name of a string, like literally name here, then a period, then the name of the function, and then an open parenthesis and a close parenthesis. Maybe some arguments inside of those parentheses, but in this case, it doesn't need any arguments. I just want to strip the space from the left and the space from the right of the user's input. But that's not enough. I want to remember that I've stripped off that white space on the left and the right, so I'm going to use the equal sign again here. And notice that just as before, this doesn't mean equality. This means assignment from right to left. So when this line of code here, name.strip, returns to me, aka a return value, it will return the same thing that the user typed in, but with no more white space to the left or to the right. So then the equal sign, assignment, is going to copy that value from the right to the left, thereby updating the value inside of my name variable. So you can not only assign values to variables, you can absolutely change the value of variables by just using the assignment operator, the equal sign, again and again and again. And it will just keep copying from right to left whatever the new value should be. So now, if I rerun this program, Python of hello.py, enter, I have DAVID. Oh, let's do it again. Space, 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 DAVID in all lowercase, space, space, enter. It's better. It hasn't fixed my capitalization, so I'm still being a little sloppy with the first D, but it has stripped off all of that extra space. Super minor detail, right? Like, this isn't all that exciting, but it just speaks to the power of what you can do with just a single line of code. Now, what else can I do here? Well, I could capitalize the user's input. Let me go ahead and try this. It turns out that I could also do this, name.capitalize. So let me go ahead and capitalize user's name. And again, I'm making comments, and there's no one right way to write the comments. I'm just using some short English phrases here to remind myself of what I'm doing. What's now going on here? Well, let me go ahead and run Python of hello.py, enter, space, 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 DAVID, space, space, enter. OK, now it's looking prettier, right? No matter how the user typed in their name, even a little sloppily, I'm now fixing that. But let's try something. I'm getting a little curious here. How about this? Space, 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 DAVID, space, Malin. I'll use my last name now. Enter. OK, so ironically, capitalize is not really capitalizing everything we want. It's clearly capitalizing what? Just the very first letter. So it turns out that, again, there's other functions in Python that come with strings. And if we poke around the documentation, scrolling through a URL like that, I bet we'll find another solution, one of which is actually this. Let's actually change this to title. There's yet another function that come with strings called title that do title-based capitalization, just like a book or a person's name, capitalizing the first letter of each word. And this is just going to do a little more work for us. So let's go ahead and run this. And as an aside, I'm kind of tired now at this point of typing Python, Python, Python all the time. It turns out that when using a command line interface like this, you can actually go back through all of your old commands. What I just did a moment ago was I hit the up arrow. That immediately goes back through my history of all of the commands I've ever typed. So this is just a faster way now for me to repeat myself than typing everything manually. Let me go ahead and hit enter. Space, 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 DAVID, Malin, space, space, all lowercase, enter. Now it's looking better. Now I've capitalized things and cleaned things up. But what about my code? I've got like 8 lines of code now, 4 of which are comments, 4 of which are actual code. Do I really need this much? Well, not necessarily. Watch what I can also do in Python. Let me not bother capitalizing the user's name separately. Let me say this, and capitalize user's name. I can chain these functions together. I can add title to the end of this. And now what's happening? Well, again, with a line of code like this, you first focus on what's to the right of the equal sign. Then we'll get to the left of the equal sign. What's on the right of the equal sign? This line here. Well, what does this mean? Get the value of the name variable, like DAVID space MALAN, then strip off the white space on the left and the right. That is going to return a value. It's going to return DAVID space MALAN without any white space to the left or right. What do you want to do with that return value? You want Python to title case it. That is, go through every word in that resulting string and fix the first letter of the first word, the first letter of the second word, and so forth. And then, now we can finish our thought, copy the whole thing from right to left into that same name variable. And you know what? I can take this even one step further. Why don't we go ahead and do this if we want? Let me get rid of all of that, and let me just do strip and title all on that first line. And now we've gone from like 8 lines of code to 4. It's a lot tighter. It's a lot neater. And even though reasonable people might disagree, it's arguably better because it's just easier to read. Fewer lines of code, fewer opportunities for mistakes. It just allows me to move on with my next problem to solve. All right, let me pause here and see if there's any questions on these methods. A method is a function that's built in to a type of value, like these functions are, or on f strings, which we saw a moment ago.
Yes, hi, thanks, David. So is there a way to remove the spaces between the spaces that I might have added?
Short answer, no. If you read the documentation at that same URL earlier, you'll see that strip removes from the left and the right, but not in between. In fact, there's 2 other functions that come with strings. One's called lstrip. The other's called rstrip that allow you to do one or the other. If we want to start getting rid of space in the middle, we're going to have to do a different trick altogether.
How many functions can we combine like this dot strip, dot title you have combined? So how many we can combine?
Yeah, a really good question. Technically, as many as you want. But at some point, your code's going to start to look really, really bad, right? Because the line of code is going to get really, really long. It's eventually going to maybe wrap around again and again. So at some point, you just kind of say, like, that's too many. And you start breaking it up into multiple lines like I did, maybe reassigning the value to the variable as needed. And this is actually a good question. If I can pivot, Divya, off your question, I mean, what do people think? If we could go ahead and put everyone's hands down for a moment, let me ask this. Is the way I've done this now with strip and title and input all in the same line better than my previous approach? In Zoom, you can use the yes icon or the no icon. If you think this version is better, say yes. If you think this previous version was better, for instance, this one here, where we had everything broken out, say no. And then we'll see why in just a moment. I proposed earlier that reasonable people can disagree, and that's absolutely the case. Doing it one way or the other isn't necessarily best, at least if you can justify it. Let me go back to the most.
Okay. I think that the name, the input function should be alone, and the formatting for like strip and title function should be together. It looks neat like that. So in my preference, it is this one. Okay. Thank you.
Recent version here. All right, so we're seeing a lot of yeses and a lot of nos. Why don't we go ahead and call on one of the yeses if we could? Someone who's voting yes, why do you think the current version of this code is indeed better than the previous longer version of the code?
I think it's more readable, so I can say, hey, this is the name variable. It gets some input, and then remove the space and give it a title, and there you go. You have a hello name.
Yeah, I think that's pretty reasonable. It's very readable, at least if you're in the habit, as you are in English, of reading left to right. It just kind of flows very naturally as a result. The line is not really that long. It's certainly fitting nicely onto the screen, so I think that's a good argument. How about a counterpoint, though? Someone who voted no, if we could call on someone who thinks this is worse.
Because it's not readable at all. It seems like it's a very long line, so I think it's better to separate.
Yeah, I think that's persuasive too, right? It's getting a little longer. And even though my sentence here, what's your name, is relatively short, you could imagine that this could get even uglier quickly. If I were asking a longer question of the user, that's going to make this line of code even longer and therefore less readable. It might be less obvious to me or my colleagues that I am calling strip or that I am calling title. It might be kind of an unexpected surprise. So I think that's reasonable too. In short, there is no right answer here. And in fact, part of the process of getting better at programming is getting your own sense of style, or working for a company where they might prescribe which way is better than the other because they just want everyone doing the same thing, even though reasonable people might disagree. Ultimately, though, so long as you have what's a pretty good argument in favor of one way or the other, like ultimately that's what's important. If you're just doing things because you don't really know which one's better, that's not great. But if and when you start to acquire opinions, and if your boss, if your teacher, if your colleague, your friend can challenge you and say, wait, why did you do it like this? They might not agree with you, but at least have an answer, and that should be sufficiently persuasive in general. Now, strings come with a whole bunch of other methods as well, among which is one called split, which can, as the name suggests, split a string into multiple smaller substrings, so to speak. For instance, if the human here is in the habit of typing in their first name, then a space, and then their last name, and you want to go ahead and greet them only by first name, well, we could actually leverage that single space between the first name and last name and split that string into two smaller substrings. How can we do this? Well, let me go ahead and in between these lines proactively comment that we're about to split user's name into first name and last name. And then let's go ahead and take that name variable, which currently contains something like, presumably, David space Malin, and let me go ahead and call split and pass in as the argument to split a single white space, thereby indicating that I indeed want to split on that character. Now, it turns out split's going to return a sequence of values, ideally a first name and then a last name, and we can actually in Python assign both of those values from that sequence at once to some variables. For instance, first, comma, last equals, and that's going to have the effect from right to left of putting the first such value in the first variable, the second such value in the second variable. So now on my last line of code, I can go in and say hello, not to the full name, something like David Malin. I can just say hello, comma, first. All right, let's go ahead and clear my terminal window, run Python of hello.py, and hit enter. I won't bother with any leading white space this time, but let me go ahead and type in David space Malin, and crossing my fingers as usual, hello, David, is what we now see. All right, so we've seen so many examples thus far involving strings, but certainly programs and programming languages can manipulate other types of data as well. Let's go ahead and transition then to another very common type of data in Python, in programming more generally, namely integers, otherwise known in Python as int, int. So just as str is short for string, so is int in Python short for integer. Well, what's an integer? Well, just like in math, it's a number like strings, but certainly let's go ahead and transition, namely integer. How many know data code? I can go in and say hello, not to the full name, something like David Malin. I can just say hello, comma, first. All right, let's go ahead and clear my terminal window, run Python of hello.py, and hit enter. I won't bother with any leading white space this time, but let me go ahead and type in David space Malin, and crossing my fingers as usual, hello. Any examples thus far involving string, but certainly programs and programming languages can manipulate other types of data as well. Let's go ahead and transition then to another very common type of data in Python, in programming more generally, namely integers, otherwise known in Python as int, int. So just as str, str is short for string, so is int in Python short for integer. Well, what's an integer? Well, just like in math, it's a number like -2, -1, 0, 1, 2, and all the way toward negative infinity, all the way toward positive infinity. But there's no decimal point in an integer. It's just a number like -2, -1, 0, 1, and 2 onward. That's an int. Of course, in the world of mathematics, there's lots of symbols that we use, and we've seen plus before, although we used it for a different purpose. But Python supports these symbols and more. And Python allows you to add numbers together, plus, subtract numbers, multiply numbers, divide numbers. And the only one here that might look a little strange to people or unfamiliar is this percent sign, but it doesn't mean percent in this context. If you use a single percent sign in a Python program, that's actually the so-called modulo operator, the operator that allows you to take the remainder after dividing one number by another. So we'll see examples of that before long, but the first 4 of these are perhaps quite familiar. Well, it turns out that in Python, you don't necessarily have to keep writing code in a file like hello.py and then running it in a terminal window. One of the features that many people like about Python is that it supports this, a so-called interactive mode. Like you can start writing Python code and immediately execute each of those lines interactively, especially if you don't care about saving all of your lines of code. You just want to execute code and get back some answers. So for instance, let me go back to VS Code here, and let me close hello.py, and let me click on the little triangle over here in my terminal window just to make it much bigger, just temporarily for a moment. So I'm not creating any .py file now. I'm just going to run Python by itself at my prompt. And you'll see when I do this, I get some cryptic looking output and the date and time at which the program was last updated and so forth. But I ultimately get 3 triple brackets like this. This is the interactive mode for Python. So I'm running the Python interpreter. And anytime I type a line of code in the interpreter, it's going to execute it immediately. I don't have to keep running Python again and again. It's as though in the human world, if you were standing next to a human who speaks some other language and you're just having a conversation with them back and forth, it's all happening, the translation, immediately. So what might I do in interactive mode? Well, I could do something like 1 + 1, enter. That's actually code. All right, you might not think of it as code, but if you know a bit of arithmetic and you know numbers and you know plus, that's valid Python code. And you can use Python really as a fancy calculator. But I could do other things too. If I want to print to myself hello, world, I can also print out that line of code there too, hello world. So it's interactive in the sense that the moment you execute a line of code, boom, you see the result. We're generally not going to do that because at least when teaching the language, we tend to want to do things incrementally. And we want you to be able to see where it is we came from. And we want to be able to try things again and again, especially if we make mistakes. But know that this is indeed a feature of Python, this so-called interactive mode. But let's focus for a moment now, not just on that interactivity, but really on the fact that Python apparently supports integers and mathematics and some of those basic operations. And let's see if we can't make maybe our own little calculator. So let me go ahead and open up VS Code again. And I'm going to shrink down my terminal window. And I'm going to create a new file called calculator.py. So to do that, recall, I can type code down here. And the name of the file I want to create, .py. Enter. That gives me a new tab up top. So I have already closed hello.py. I'm now in calculator.py. And let's just make a simple calculator that does some addition for me. But I'm going to do it in a file. Operations. And let's see if we can't make maybe our own little calculator. So let me go ahead and open up VS Code again. And I'm going to shrink down my terminal window. And I'm going to create a new file called calculator.py. So to do that, recall, I can type code down here. And the name of the file I want to create, .py. Enter. That gives me a new tab up top. So I have already closed hello.py. I'm now in calculator.py. And let's just make a simple calculator that does some addition for me. But I'm going to do it in a file so that we can iterate on this and make changes for better or for worse over time. Let me go ahead and first declare a couple of variables. I'm going to do the mathematical thing of calling my first variable x, my second variable y, and then I'm going to give myself a third variable, z equals x plus y, and then I'm going to go ahead and print out z. Now, this program, admittedly, not very exciting or interesting. In fact, it's a little less interesting than printing stuff on the screen like before with strings. But we'll build on this and see what other features exist in Python that we can leverage. So hopefully, if Python knows its math as well as I do, when I run python of calculator.py, I should see, hopefully, that 1 plus 2 equals indeed 3. All right, so not that surprising and not that interesting. And honestly, this isn't the most useful program because it's always going to calculate 1 plus 2 equals 3. Let's at least make this program, say, a little more interactive, right? We already know from previous examples how we can get input from the user. Let's bring back that input function. And let's do this. Let me go ahead now, and at the top of my code, let's change x to not be the number 1 always. Let's change it to be whatever the return value is of asking the user for x. And I can use any English or human language I want here. I'm going to say, what's x? Just like I asked before, what's your name? And I'm going to do the same thing for y. I'm going to use input again, but this time change the question to be, what's y? All right, at this point, I think I'm going to leave the rest of the code the same, z equals x plus y, and then print z. But what's nice now is that I think I have a nice interactive calculator. Right now, it's not going to do 1 plus 2 all the time. It's going to do whatever the user types plus whatever the user types. So let's try this. Let me go ahead and run the program. All right, let's do it. 1 is going to be x. 2 is going to be y. And of course, everyone in agreement, 1 plus 2 equals 3. Huh. What's going on there? Either your math class misled you or I have misled you. Why don't we call on someone here to see if you can't help us reason through what the bug is? What's the mistake? Anjali, if I'm saying it right?
I think the issue is that it's concatenating strings because you use the plus operator instead of adding.
Perfect. So perfect intuition. We've seen that plus is used a little differently in the context of strings because it concatenates. That is, it joins the two strings. And that seems to indeed be what's happening here, even though the user typed a number. But the interesting thing here is that when you get user input, because they're using a keyboard on their Mac or PC or their phone, it is always going to be text. It might look like a number, but by default, it's coming from the keyboard as a string. That is as text. And so how do we go about resolving this if ultimately we don't want to treat those inputs as strings? We want to treat them as actual numbers. Well, we need another function. And it turns out in Python that you can convert sometimes from one type of data to another type of data, for instance, from string to int, by doing something like this. Let me go back into my code, and let me change x before adding it to y to be whatever the integer version of x is, plus whatever the integer version of y is. So it turns out that int is not only a type of data in Python, it's also a function. And it's a function that if you pass in an input, like a string, so long as that string looks like a number, like 1 or like 2, it will convert it to an actual number that you can perform mathematics on instead. So if I now go back to my terminal window and run Python, and let me show you another trick. Calculator is kind of a long word. It's a little tedious to type. Notice what I can do in my terminal window in a command line interface in general. If I start typing CAL for calculator, I can actually hit tab to finish my thought. So autocomplete is possible in a terminal window like this. Type the first letter or few letters, and then boom, with tab, it'll finish your thought for you. Or you can go back in your history like I did with the up and down arrows. Let me go ahead and execute this. What's x? 1. What's x? 2? And there we go. Now we have a general purpose calculator that's going to support not just addition of 1 and 2, but now any two integers that the user types. And let me now improve this, right? We've seen how we can make improvements to code. And I don't know if it's going to necessarily be better, but let's try this. Do I really need the z variable? It's worth noting that I'm creating a variable called z, and then I'm immediately using it on the next line of code. Now, That's not that compelling, because if you're creating a variable and then immediately using it but never again using it, did you really need to take the time to introduce another symbol and another variable just to use it once and only once? Well, maybe not. Maybe we don't really need z in this way. Maybe I should go and do something like this. Maybe I should get rid of z here. Maybe I should change this to be int up here, change this to be int up here, doing something that's pretty interesting now. Even though it's a bit of new syntax, notice that you can nest functions, so to speak. You can put one function call, that is the use of a function, inside of the use of another function, so that the return value of the inner function becomes the argument to, or the input to, the outer function. So just like in math, if you have parentheses, 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 your teacher probably taught you to focus on what's inside the innermost parentheses first and then work your way out. Same thing with programming. That's what Python's going to do. It's going to look at what's inside of the parentheses first. It's going to get the answer, and then it's going to pass the return value to the outermost function. So what happens on line 1 now is that the input function gets called first. Then the result of that, quote unquote 1, becomes the input to the int function. And same on line 2. The output of what's y becomes the input to this int function. And now there is no z. I could just do print x plus y. And because I've taken the time to convert each of those strings to an integer, I think we're OK. So let me try this. Python of calculator.py, enter 1 and 2. And we're still getting 3. Not 12, or not 12, 1, 2. We're indeed getting 3. And we've additionally gotten rid of the variable because we didn't necessarily need it, it seems, especially if only using it once. Well, here too, let me put everyone's hands down for just a moment, and let me ask, as before, this version now, which uses int around the invocations of input and does not use z, is this better than the previous version? If you want to vote yes, go ahead. Or if you prefer the old way, vote no. The old way, I'll undo all of this as we vote, instead looked like this. All right, and let me go back to now the newest version. Let's take a hand of the yeses. Someone who thinks this latest version is better.
I think this way is better because it allows us to immediately see what the x and y variables are with integers, and so we know what to expect from them. And also the print argument is more intuitive. We avoid too much clutter in the code.
I think those are all good reasons. It's nice and succinct. The lines of code are not very long. I don't need to know what z is because it doesn't exist. It just see print x plus y. I like that. But someone who prefers the older way, where we did have z and we more explicitly passed individual variables to the int function.
Yeah, hi. I think the earlier version is better because when, I mean, if user input something else other than int, let's say they type 1 and 2, like, so it will be easier to debug.
This version, or this version here, or the old version?
The old version.
OK, that's fair. And in fact, I'm being very careful today as best I can not to mess up. I have thus far only inputted integers when I'm expecting integers. And Raul's actually pointed to something we'll come back to in the coming weeks. How do we actually handle errors? What if the user doesn't type in the number 1 or the number 2 or a number at all? What if they type in a word like cat, C-A-T? That's not a number, and I bet I can't convert it to an integer. But for today, I'm not going to focus on that. I'm just going to hope that the user cooperates, but that's not going to be the case. And so perhaps one way would set us up for more success when it comes to handling those errors. Now, for today's purposes, which is better? I mean, I like both. And I think both of you made very valid arguments in there, too. So long as you have a justification that feels pretty reasonable, I mean, that's what ultimately matters. But acquiring, again, a sense of the trade-offs here. Well, is this way better? If so, why or why not? Just understanding what those trade-offs are. But generally speaking, prioritizing readability is a very good thing. Making your code readable for someone else is a very good thing, and very good for you too, so that when you wake up the next morning or you come back the next week or the next year, you too can read your own code without having to waste time trying to remember what you did. And simplicity tends to be a good thing too, keeping your code simple. So as you get more comfortable with programming, you might be tempted to try to combine an entire program into one long line. For instance, let me do just that. technically speaking, we don't really need x in a variable. We don't really need y in a variable. We could also do this. I could just get rid of x and y altogether. I could then now eliminate that and make it just one line of code. OK, so in some sense, you might be inclined to think, wow, that's really nice. You made it one simple line of code. I would argue this actually isn't that simple. Now I think I'm starting to nest too many things. I have to think about print and int and input. I then have to notice that, OK, I've opened 2 parentheses. I've closed 2 of them. There's a plus. You're making me think too much. And anytime you make me think, you're wasting time. And anytime you complicate the look of the code like this, you're just going to increase the probability of mistakes, syntactical mistakes or logical errors in your code. So of all the things we've done, this is the only one that I would argue, yes, it's one line and it's nice and compact. It's just not readable enough. I would shy away from doing this, especially since 2 of those function calls are getting input from the user. But there too, reasonable people might disagree. But that's the kind of like visceral reaction you should have sometimes when code starts getting a little too complicated, a little too clever, perhaps for its own good. All right, well, it's not just integers we have access to. Let me propose that we transition from integers to one more data type here, namely a float. So again, a string is a sequence of text. An int is an integer, like -1, 0, and 1. A float is a number with a decimal point, properly called a floating point value. And you can think of the floating point as being the decimal that might be over here or over here with some number of digits to the left or the right. Mathematically, it's a real number, a number that has a decimal point in it. So that's a third type of data that Python supports. Right now, our calculator is somewhat naively assuming that the user is only going to type in integers. But if I want to support floating point values too, I think I can just make a couple of tweaks. So I'm going to go back to VS Code here. And instead of just converting the user's input, x and y, to integers on line 1 and 2, let's just make a simple change. Let's actually convert it to a float on the first line and a float on the second line here. Now I think if I go down to my terminal window and run Python of calculator.py, let's type in a number like 1.2 with a decimal point and 3.4 with a decimal point, and there we go. We have 4.6 as the final answer. So that wouldn't have worked before if I was only expecting integers from the user. But now that I'm expecting floating point values and accommodating it, I can actually now do floating point arithmetic as well. But suppose that I don't really want the final answer to be a floating point value like 4.6. I would be happy if we just round to the nearest integer. So I want to support the user typing in floating point values with decimal points. But at the end of the day, I just want to round the result to the nearest possible integer, for instance. Well, it turns out that here too, Python comes with some functionality built in. And in fact, if we return to this URL from earlier, wherein all of the Python built-in functions are listed, there's one called round, which does exactly as we would expect. It takes as input a number and then rounds it for us, for instance, to the nearest digit, to the nearest integer. But if we look a little closer at that documentation, as we can here, I'll provide an excerpt. This is what the function looks like in the documentation. And recall that earlier we looked at the documentation for print. And this is similar in spirit, that this shows us not just the name of the function, but its available parameters. That is, inputs that we can provide when using this function. But this is a little cryptic too, just like print was, and it adds some syntax. So let's see. The name of this function here is, of course, round. And its first argument is a number. Notice this time there's no star. There's no star objects like there was for print. The round function takes just one number as its first argument, period. That's its positional parameter. But notice this syntax. And this is a convention in programming or technology more generally. Generally speaking, when you see square brackets in documentation like this means that you're about to see something optional. And so what this means is that if you want to specify more precisely the number of digits that you want the round function to round to, you can specify it here by adding a comma and then that number. So if we read the documentation, if you don't specify a number of digits, you just specify the number to round, it rounds to the nearest integer. But suppose you want to round to the 10th place or the 100th place, that is 1 or 2 digits after the decimal point, you could additionally pass in comma 1 or comma 2 to be more precise. So that's what the documentation there is saying. Let's see if we can't then translate this to some actual code for us. So if I go back now to VS Code and I consider that I want to go ahead and round x and y, I can do this in a couple of ways. I could do round x plus y, but you know, I'd actually kind of prefer to break this now out into two lines. I don't have to, and reasonable people here might disagree, but I'd like to revert to a scenario where I'm printing z so that I can just a little more clearly to myself, to others, say z equals the rounded result of x plus y. It's not necessarily the better way to do it, but I'm a little more comfortable with breaking out my thoughts one at a time, especially if I want to start commenting each of these chunks of code. All right, let me go down to my terminal window now and run python of calculator.py. What's x? Let's do 1.2 again. Then let's do 3.4. And now it was previously 4.6, but now it's been rounded up to the nearest integer, which of course is going to be 5. All right, what if I wanted to change this a little further? What if I wanted to support maybe really big numbers, irrespective of rounding? Let's just do something like this. Let me go ahead and run python of calculator.py again. And let me just add 999 plus 1. And notice I don't have to type decimal points. Even though I'm converting to float, my program will just allow me to type decimal points, but I don't need to oblige. The answer, of course, here should be, and is in fact 1,000, whether or not we round. So that's just arithmetic with integers here. But in the US, we tend to format long numbers by putting commas after or before every triple of digits. Other countries flip it, and they use periods and commas instead. That's a system setting. You can change that on your own Mac or PC or device for Python or any language. But for me, I'm using the US approach here, which is periods for decimal points and commas for separators. What if I wanted this to be outputted as 1, comma 000? Just to make it a little more clear that it's 1,000 and not something like 100. That's even more useful when it's like 1,000,000, 1, comma, 000, comma, 000. Wouldn't it be nice if we could automatically output those numbers as well? Well, it turns out that we can. There is a way using Python to actually specify that we want to include commas like this. And here we have an opportunity to bring back our old friend, the f string. First, let me do something that's not that productive. First, let me do this. Let me print out the value of z. But wait a minute. I can't just say quote unquote z, because that's literally going to print z on the screen. So let me wrap it with those curly braces like I did before. But that too was not enough. I literally needed to add an f at the beginning of my string to tell Python that this is an f string, a format string. That now is going to print out, not very interestingly, just the value of z itself. So that I'm going to great lengths just to print z, when really I could have just passed z as the sole argument. But just to ensure that I haven't broken it, let's do this again. 999 plus 1, enter. OK, it's still 1,000. So I didn't make anything worse. But notice, and this syntax is unfortunately a bit cryptic, notice that I can actually do this. I can put a colon after the z, and I can put a comma thereafter. This looks very cryptic, admittedly. And even I have to constantly look things like this up in the documentation to remember the syntax. But here, let me run it again. Python of calculator.py, 999, 1, and now notice that the number has been automatically formatted for me. If I were in a different country or locale, I could absolutely override this to use periods instead of commas or vice versa. But in this case here, it's just happening for me automatically. So there, too, we see a hint of what it means to really format a string. There's even more power, more powerful capabilities built into that. All right, let me pause here to see if there's any questions now on floats, on rounding, or on this use of f strings.
Yes, so I have a question. So when using floats, is it like a cap to how many decimal points it can have?
A really good question. So floats, yes, and this is a problem we'll revisit before long. Floats cannot represent numbers infinitely precisely in a nutshell because computers only have so much memory. They only have a finite amount of memory. You and I only have a finite amount of hardware inside of the computer. So at some point, they're going to have to round. Right now, I'm rounding automatically. Effectively, computers will eventually have to do that for us. But we'll see that as a fundamental problem before long. Allow me to turn back just for a few final examples on float before we introduce a few final examples that allow us not just to use functions, but to make our own. Let me propose that we also try our hand at a bit of division here.
Okay, so for today, I think we'll stop it here. We'll continue tomorrow from division to the end. We'll complete it tomorrow. I'll think we'll sit tomorrow for half an hour, 1 hour, and then I'll complete it. Okay. Ultimately, we have only 1, 2, 3, 4, 5 topics left. So we'll revise the notes tomorrow from this notes tab. Okay, then we'll start watching half an hour. I think we'll revise it for 15 minutes or something, 15-13 minutes. Then we'll proceed to watching the remaining video, and then we'll revise if we have time. We'll revise it afterwards. Maybe tomorrow I'll complete it fully. Then we'll continue with the week 2 lectures. Okay, so think yes, that's it for today. Thank you for watching. Goodbye. Have a happy new year. Thank you.